In this lecture, we're going to talk about Polypaint from Thikness. This is a valuable tool when you're working with Decimation Master and exporting models for 3D print. This is the troll that we used in our Decimation Master tutorial. Now, the troll has already been decimated, as you can see. And I've got two trolls here. We've got this one, which is also decimated, and this one. They're currently identical. We're going to create a wall thickness in one, and we're going to leave the other one as a solid volume. So we'll begin with this one here, and I'm just going to go ahead and turn on solo mode so we're only seeing the head itself. Now what Polypaint from Thikness does, you'll find it down here under Tool, Polypaint from Thikness. What Polypaint from Thikness is going to do is it's going to give you a color-coded Polypaint layer, which will tell you what parts of your model are too thin for 3D print based on your minimum and maximum thickness. So this is going to be scale dependent. Now, remember, if you've watched the video on Scale Master, ZBrush is what I like to call unit agnostic. It uses an internal scaling unit, and you need to tell ZBrush what the size of your objects are inside the program. We do that under the Z plugin menu, Scale Master. Now, I'm going to determine what the scale of this tool is by going to Set Scene Scale, and this is going to give me a variety of unit measurements which ZBrush thinks may apply to this object. So we're going to pick the one that seems to be the most pertinent. In this case, it's 6.26 inches in the Y direction. So this is 6 inches tall from the top, or 6.26 inches tall from the top to the bottom. Now that's going to be the size when it's 3D printed. Now obviously the overall scale of the object is going to control the overall thickness of the surfaces. So if this were being printed at 6 millimeters, this ear would be considerably thinner and might present you with problems in 3D printing. Now, the Polypaint from Thikness gives you this color-coded warning system. If you're working with your own personal 3D printer at home, this may be very useful. If you're working with an online print bureau, say for example someone like shapeways.com, they're going to have an online system where you upload your object as an STL or an OBJ file, and then you'll be able to process it on their website and actually see what they call a temperature map, or what this is called a temperature map essentially, which will show you areas that are too thick or too thin based on their printer. So let's go ahead now and create the Polypaint. So I've got it set to From Thikness, set the minimum to 1 and the maximum to 5. Now I'm going to click From Thikness, and we have Polypaint on the model right now, and this is going to replace the polypainting. So you might want to do this on a separate copy of your mesh if in case you want to export your Polypaint with the object, or you can undo back before the polypainting is replaced. So it's ray casting right now from the origin, and those rays are determining when they touch the surface of the model, and if they touch another surface of the model, it will record the thickness of that particular shell. Now this is a solid volume for printing, so the areas that you're likely to have problems are going to be on the tips of the ears, maybe the wings of the nostrils. And here we go. Here you can see, based on our object scale, the areas in red are the areas that are a potential problem that you might need to thicken. Now, because we have eyeballs in this mesh, the eyelids may not be quite the problem that they appear to be. The tips of the ears are looking pretty good. You can see along edges, along sharp edges here, we do have some red. In my experience, these areas haven't been that much of a problem. It's if you get the entire tip of an ear too thin, then you'll find that it'll be red. Let's change our overall scale. I'm going to set our scale. Let's go ahead to Set Scene Scale, and let's set this instead to millimeters. We'll set it to, let's see, well, let's go ahead and set it here. I am going to set the overall size to, let's say, 2 inches tall in the Y direction. So let's go ahead and resize subtool. There we go. So now we've resized this to 2 inches in the Y direction down from 6. Let's do our From Thikness again, and you'll see this update. Now remember, if you take an object and scale it down, anything that's thinner at a larger size is going to be even thinner at a smaller size. And this, of course, is going to be dependent on your printer. However, it's always best to avoid surfaces that are entirely too thin. And here we go. There we are. Now you see it's updated, and we've got a lot more problem areas through the ear here. We've got problems in the eye and along these border edges here. And that's just where that angle comes together. You could correct that with a little bit of a bevel, but as I said, I don't usually find angles like this to be quite as much of a problem. It's protruding shapes like this ear, horns, spikes, things like that that will present the most challenges. So let's go back to our subtool menu and select our other troll. So for this troll, we're going to create a wall thickness. Now, we did wall thickness in the chapter on Decimation Master, but we created a hole so we could see into the volume. Now, that was often used with 3D printers that had a wax-based support structure, so it could drain out of the interior. Most 3D printers now don't have that. They'll be using a solid support structure, so you don't need to have a void there. However, there may be other cases where you do want to have an opening in your shell, so it's good to know how to do it. In this case, we're going to create a shell thickness without an aperture. We'll do that the same way. We need to Dynamesh the model. So I will come down here to Geometry, Dynamesh, and we'll set our value up probably around 400 or so. We want to make sure that we don't lose any of our surface detail, and then we will just click Dynamesh. And here you can see we have Dynameshed our model, and we're maintaining our details. Now I want to create our shell. Now to do that, we'll go to B for brush, I for insert, select the IMM primitives brush and grab the cylinder. I'm going to hold down the Alt key. Now my alternate color is black, so I'm going to switch to white so it's easier to see this. Hold down the Alt key and then draw that cylinder. And I press W to bring up the gizmo, and then we move it out of the model. We don't let it countersink into the model this time. So now we've got this negative value insert. We have our model, which is masked. We'll clear the mask. Then, instead of executing Dynamesh, we will create shell. ZBrush will start to process that, and in a moment, we'll have our shell thickness. Now that has completed processing, but we won't see anything on the exterior of the mesh. However, if I were to hide a portion of the mesh, and then we look on the inside, you can see that we have a shell thickness. If we go to Display Properties and turn on Double-Sided under the Tool menu, you can actually see that thickness here. So previously, where we used Polypaint from Thikness to determine the thin areas on a solid volume, this time we're going to use it to determine the thin areas between the outer shell and the inner shell. So we may run into areas where it's too thin within the surface of the model compared to just in the tips of the ears or horns, for example. So we'll go ahead and click From Thikness, minimum 1, maximum 5, and this is going to generate based on our object scale, which is 6 inches from base to top of head. So let's go ahead and click From Thikness, and it will begin to do a thickness analysis. It shouldn't take too terribly long. And it's going to replace the Polypaint with the heat map that will show us a color-coded guide to the areas that are thick enough all the way down to the areas which are dangerously thin. And here we go. So you can see now that we've got a brand new heat map, and let's zoom in here and take a look at these colors. So how do we understand these colors? Red is going to be beneath the minimum range that we've set here. So that's beneath 1 unit. So any areas that have the red, those are potential problem areas. So down here, this is quite likely too thin in the inner shell, so I'll just need to pull that out. Areas like this are probably too thin along that edge. Now, Areas that are pink, those represent the minimum range itself. So this is actually right on 1 unit distance from the inner shell. The green or the yellow areas, let's see, like this area here, all these yellows, this is pink through here, but here you can see the yellow. If we change to the flat color material, it might be a little bit easier to spot some of this. There we go. So the areas that are yellow, those areas are going to be 1 increment beyond the minimum distance. So that's getting into safe range. Areas that are green, which we only seem to have 1 here, the tip of that ear, that is 2 increments of distance beyond the minimum. Now, we don't have any purples or blues here. As we get up towards purples and blues, we are at 3 instances away from the minimum range to blue, which exceeds the maximum range. So blue would be, you know, a very, very good value to have. But as long as we're not getting into reds and pinks, we should be fine. So it looks like some of this could be improved. So what I will do is, let's go to frame mode. Let's go ahead and go back to our basic material too. So let's go ahead and redo our thickness. I'm going to undo this, undo again, undo again, undo again, undo again, and then let's set our thickness. Let's go back to Dynamesh, and let's turn this up to 16 and create shell. And now it has completed that wall thickness, so let's go ahead and hide part of the mesh again, and we can see just how thick that is. Let's go to display properties, turn on double-sided, and there we go. We have considerably more thickness now. Going to go ahead and set sliders to subtool size. Just want to double check that it's 6 units. It is still 6 units. So now let's do our from thickness again. So min and max, and let's go ahead and do our from thickness. So that'll regenerate that map, and we should see that we get some different values in there. And there we go. So now you can see we have a considerable difference in our map based on that thicker wall thickness. So here we've got some red areas along the edge of the ear and the eyelid and some in the gums. On this hard angle around the border, we've got a little bit of red. But otherwise, we have mostly, that's sort of the light blue. That would be, as I said, 3 increments beyond the minimum range. And the yellow is going to be probably safe. That's 1 increment beyond the minimum range. It's just the pinks and the reds we're concerned about. And here you see that we've got this blue. That blue exceeds the maximum range factor. So this is actually quite a good value here. So if we want to adjust anything, we can go in with the inflate brush or smooth brush and try and resolve some of these areas. So if I go into frame mode, take a look at my mesh here, maybe we'll take the inflate brush, just do some inflating. Let me undo that and leave frame mode. And let's do a little bit of inflate along here. We'll overstate it a little bit so it's quite obvious the changes that we've made. And I will take the clay tubes brush with no alpha, and let's go ahead and just thicken this whole area. So if we do some sculptural changes here, you can see this change. Smooth this back a bit, and make sure when you smooth, your RGB is turned off. Otherwise, you're going to end up smoothing that map, and you're not going to be able to see the values as clearly anymore. We can go ahead and do a little bit of sculpting of a draft in there, and then we will do from thickness again. So we'll calculate that map again. If we watch this area, we can look for any updates in the portions that we've sculpted. Those areas that are pink and red, which are potentially the most problematic. Now, I doubt that that's actually calculating based on the wall thickness going into the inner shell. That's most likely the thickness of the earlobe itself, wall to wall there. Same with the tip of the ear. And there we go. We see that value has vastly increased or improved. We can do the same with the tip of the ear, the eyelids. Basically, you can go in and spot adjust these things using the inflate brush, clay tubes brush, things like that to resolve the surface. You could also utilize the Sculptris Pro mode so you can tessellate as you're sculpting if you're working on something that is not a Dynamesh. So that completes this look at Polypaint from Thikness. It's very, very valuable as a diagnostic tool, so you know exactly the strengths and weaknesses of the mesh that you plan to send to 3D printer. So I hope you found this video useful, and I will see you in the next chapter.